Yeah. Is everybody seeing that? Recording is in progress.
The slides are
Coming
visible.
across.
Slides are
Slides are
visible.
good.
Thank
Okay,
you.
great. Thank you very much. Well, welcome everyone. Let's get started. I'm sure a few participants are at, some more are dropping in, so that's great. Welcome everyone to Persistent Identifier Interest Group session at this plenary. Really happy for you to join us. The goal of today is a discussion. We've got some presentations to stimulate thought, but feel free at any moment to dive in with any questions, respond, and we've got Josh and myself are going to co-chair today meeting. We have Larry Lanham, Giordano Manapelli, and Amir Ariani who are going to talk. And really what we're interested in is an open discussion, stimulating discussion on what we think the impact of AI will be on persistent identifiers, and perhaps more relevant on the systems. And by impact, I mean, whatever, positive, negative, just what do we need to be aware of? What is the advice that we think others should be aware of? Just to welcome anyone who's new to RDA, or for those of you who are not new to RDA, just to remind you, the RDA is a wonderful organization and a community, but it thrives because of the guiding principles: openness. We're very much community driven. There's a consensus. We look for harmonization, definitely inclusivity, and we've actually tackled that in the past in our sessions, and non-profit and technology neutral. So with those in mind, I think those guiding principles are what bind us as a group. So welcome if you're new. Feel free to ask questions, please. Any questions are welcome. If we can't answer them, maybe we know someone who can. There are collaborative notes if you've attended other sessions that you'll know this. And there's a post in the chat. I will do it again just right now. There's a link in the chat. You can also scan this QR code. Please sign in with your name, affiliation, email address. That would be very helpful at the very least. And if you can, it will be super helpful to write down any thoughts or questions or anything really in the collaborative notes, because that's something that we keep for afterwards. As I said, questions anytime, either use the chat or just raise your hand. We've got, what, 43, 44 participants, so that's not a huge group. We'll spot it. We've got 3 co-chairs here, so we'll find you, and it'll be great if that you took part in the discussion. So just an introduction to the Persistent Identifier Interest Group. My name's Jonathan Clark. I'm one of the, I didn't introduce myself, dear oh dear. I'm one of the co-chairs, along with Josh, who's right there.
Hello, everyone. Good to see so many people here today.
And Nobuko Mirai, who's joining us from Japan.
Hello.
Hi, welcome. And our 4th co-chair is Adrian Burton, who is in Brisbane. Though some of you might know him, he's in Brisbane and it's a bit late for him. But plug for his, at the next plenary, which will be in person in Australia, he'll be running a sort of follow-up session to this one. So definitely look out for that. So who are we? Well, what do we? We're all about persistent identifiers in the broadest possible sense. We think they're foundational to everything we do. And knowing what's what and where to find it is just key to all of our work. And so it's sort of the foundation upon which an awful lot of our ecosystem is built. But what do we do here in the interest group? Well, we try to be a really open place to share anything that is identifier related, exchange information. We've had sessions in the past where we've showcased new applications or new tools. Other discussions have led to, as we talked about persistence, we've had quite a lot of different ways. It's also an opportunity for you to ask any PID related questions you have, whether it's on the topic of today or not. That's one of our goals, is really to try and bring questions and experts, or questions and answers together, really. And if the chairs can't answer you, there's bound to be someone in the audience who can. What we try to do is address important and emerging PID related topics, which is sort of why we came on today, partly triggered by the whole theme of this plenary. But I talked to a bunch of people that run PIDs, and AI is exercising all our minds. What does it mean? What does it mean for us? What do we need to do? What might it mean in the future? So this is the agenda for this session. Afternoon for me, early morning for others. We're in the introduction. It's me. I'm going to hand over shortly to Larry Lanham from CNRI, who's going to send us a postcard from the future. And then we'll move on to Giordano Manapelli, who's going to talk about some of the work that he's been involved in the movie industry. That's, well, it's all super interesting, but that, I think, is a nice take on it. And Amir is going to talk about, well, you can see the title for yourself, the role of AI in the transformation of our scholarly communications. So these are much designed to stimulate you, and then we really want an open discussion. What does it mean? What should we be looking out for? Where are the bears along the way? Where are the really great opportunities that we should be going for? And where next? And if possible, if there are topics you think, oh, this would be really, really good to talk about it further, then that's what we'll take forward to the meeting in Brisbane. So with that, I'm going to stop my share and hand over to Larry. Welcome, Larry. Those of you who've been here before or anywhere else in RDA world will know Larry. I think aside from being director, he's done everything in all the the roles and the technical boards and all the others. Larry Lanham, CNRI. Don't think you need any more introduction, do you?
Okay, well, all right, here I am. So Jonathan asked me for a postcard from the future. Happily, one arrived. And here it is. So, greetings from 2035. The Earth is a smoking ruin and you are all to blame. Just kidding. We're great kidders here in the future. We have to be. I know because I was there in a certain way that you are discussing persistent identifiers and artificial intelligence. All the Time Lords will let me say is that you must proceed carefully. AI needs PIDs, but much will change in the next decade. Bye for now, Larry's AI clone, who replaced Larry about 2032. All right. So if we're going to talk about AI and PIDs and PID systems, we should put down a bit of a marker and make sure we know what we're talking about. There are lots of ways to cut this, of course, in this group. But in a network context, identifiers identify and reference digital entities. That's true even if the digital entity is a surrogate of or otherwise describes a physical entity. We don't move physical things around the network. We move digital information around the network, and that's the purpose of these identifiers. In a well-designed system, the identifier lets us get to and use the identified entity. That's the purpose of it. And you want a surrounding infrastructure that provides a variety of essential services. Persistent access over time as many things change. Access methods, locations, ownership. These things will change over time, and we want access to these objects. They have value over time, and we need access to them over time. Likewise, we need persistent access to metadata for enhanced processing over very large numbers of objects. We need ways to manage these objects. We need to know what they're about. We can't absorb every object and examine it one at a time. We need ways to do that at scale. We also need, and this is going to increase over time, I believe, trust and verification metadata, like cryptographic guarantees, assertions from trusted parties, and so on. This is going to be growing. And here I might waffle a little bit on this, but for anything like the current systems, we need the ability to put identifiers into registries in order to group objects in ways that are useful for managing information. And so the question that I think we need to address here is, how will AI play into these existing and evolving structures? And what, if anything, can we or should we do about it now, today? That's the discussion. So I think there's two basic issues. That's one way to do this analysis. Will AI eliminate any of those current functional requirements? Does any of this go away? So these are the reasons we create and use PIDs today. Does AI change that? If yes, all of them or just some of them? If no, will AI change the way those requirements are fulfilled? Now, just as we discussed what persistent identifier and persistent identifier systems are, to talk about the impact of AI, we have to more or less agree on what AI is. And that's not an easy question. It's everywhere now, and to a certain degree, every advance in computing now is called AI. You could try to define it as machines performing tasks traditionally associated with human intelligence, not to be confused with the normal advance of automation programmed by humans. But of course, we're at this AI event horizon, perhaps because of enhanced computer development and use. So it's not always easy or even useful to tell the two apart. You could think of use cases, automatically assigning PIDs to objects is something we know how to do already. That's not AI. Systems that control what gets assigned identifiers and at what level of granularity, that might be something that requires the alien intelligence that is AI without humans. All right, so first question, will AI eliminate any of these current functional requirements? Well, it's certainly not going to eliminate the reference. I mean, to manage entities on networks, you need to be able to reference them, no matter what's doing the management. Otherwise, you just have a mishmash of ones and zeros floating around on computers. So you need a way to identify objects and access them and manipulate them and use them in some sense. So that certainly has to be there, even if the use of the identifiers and the creation of identifiers is entirely in the realm of artificial intelligence. Metadata, same conclusion for metadata. The need to connect additional data over time to a given object will continue to be needed to build bodies of knowledge over time. That's what we anticipate. We anticipate larger amounts of data connected in more and more ways to lead to more knowledge discovery, and the ability to mine this enormous amount of data. So metadata has to be there. Trust, this will especially continue to be important. And identifiers are ways to connect objects to modes of trust, perhaps including ways that we don't currently envision. But we will certainly need more trust as the amount of information grows and the ability for us to know what's true, what's not, who says it, is important. And finally, registries. As I said, I might waffle a little bit on this. Anything resembling the current information environment, you need to group objects ahead of time. It may be that becomes entirely dynamic at some point if you have enough computing resources and so on. But for now, you'll want to establish registries in which you add identifiers which point at the objects. All right. So my conclusion is no, it won't eliminate the current functional requirements at this high level of functional requirements. These things seem fundamental to me in the management of information, regardless of what sort of system is managing the information. So, will AI change the fulfillment of any of the current functional requirements? What will change? All right, I think the answer is yes. The building and maintenance of ID-based reference may change dramatically by AI. For example, consider a scientific workflow done in great bulk and amazing speeds, and you need to react quickly at not human level speeds. You need to have systems that understand what products are worth identifying, how to identify them, and at what level of granularity, and intelligently monitoring the objects to keep the link between the ID and the object itself as they change and move. perhaps including approaches not currently imagined at all. We shouldn't imagine that we shouldn't think that the current approaches will just get faster and better and easier and cheaper. That's always been the problem predicting the future. Something different may happen. Excuse me. Metadata, constructing networks of connections across objects, including patterns not otherwise observable by humans. Layers of metadata beyond what is now possible. This is part of the notion that you would have AI systems roaming the world of digital data and discovering things that we currently are incapable of discovering at the human level of operation. So we'll need more metadata, faster, et cetera, and I think that might be changed dramatically with AI. Trust more so than any of the others even. We need new forms of trust and new approaches to monitoring all aspects of trust. And I think that will probably evolve from AI systems in ways that are currently unimaginable. It certainly will be a requirement, and I believe it will change. Registries, again, given sufficient compute power, I suppose it's possible that future registries will be completely dynamic and entirely managed without human input in some cases, but I don't anticipate that happening very soon. All right, what are my conclusions? The basic functions of persistent identifiers and their systems will continue to be needed in a world of AI-based information management. The use of AI will proliferate in areas both upstream and downstream of PID generation and use. The inclusion of AI in everything technical right now is a current expectation, not an open question. Can't be ignored. It's here now. And certainly the expectation and my prediction is that they'll have a great impact on how we manage all this. The construction and maintenance of these systems will change as AI continues to disrupt the world of computer programming and network management. This is anybody who's involved in IT knows this is true right now. If you're not at least experimenting with AI, you might as well be punching 80-column cards. And at some point, I should mention, anybody in the audience who hasn't gone and tried these things other than just asking Google a question, do so. Try Notebook LM from Google. Create a topic, ask Deep Research, DeepSeek, all the others. Turn it into a podcast. It's kind of amazing. You don't just read about it, try it, and you'll see that things are changing. This could, and I think probably will, impact the organizational aspects of PID systems. And there's a tension here. Reduce the level of human effort currently required to build and maintain persistent identifiers, much as advances in networking and compute power have changed the way we currently manage the systems compared to a decade ago or 20 years ago. But at the same time, increase the importance of scope of PID systems as larger and larger information networks are built, connections are made, research accelerated, decision-making, innovation, et cetera, et cetera. All these are possibilities. So this may turn out, I was thinking when I wrote this bullet about the number of people involved in maintaining the DOI back-end resolution system. It's the same number of people as we had 20 years ago doing it. It's just we're doing it 10 or 100 times as much. Something may happen similar to that. So what's my takeaway? AI needs PID systems, but will change dramatically the way they're built and used. That's absolutely happen, probably in the near future, to say nothing of a decade from now. Existing organizations, the people, in this meeting, many of them, must exercise care over this coming shift in order to maintain and, if possible, increase the level of integrity and trust in future PID systems. So that's not very determinative. I'm not telling you what you have to do. I'm saying you have to pay attention. That's the end.
Great, thanks, Larry. I've got a couple of questions, but I'm going to save them to the discussion. Are there any? One came in. Oh no, it's a comment from Son Young Kim. There's a good reference about desirable characteristics of PIDs by John Todaki and Todd Carpenter. Wonder if this needs to be revisited considering emerging AI technology. There's a link to that. Maybe take a look at that and come back to it. Does anyone else have any questions, comments at this stage? Or rather hold them till later? Seeing no hands or in the chat, then I'm going to hand over to Gerda. Thank you, Larry. Thanks very much. Very thought-provoking. So Gerda, as you can see, Vice President of Software Technology and AI at Movie Labs. Movie Labs is the organization that helps the movie industry identify films and all the things associated with film, well, actually AV in general, so all sort of audio-visual objects and other items in the movie and TV world. I think that's probably it. Is that good enough, Gerda?
Yeah, that's good. I'll possibly say probably say a couple of more words about Movie Labs in a second.
Go ahead, please. It's all yours.
Hi, I'm Giridhar, and as Jonathan said, I work at Movie Labs. But prior to working at Movie Labs, I used to work at CNRI for nearly 16 years. So Larry and I used to give back-to-back presentations for a few dozens of times. So it's good to keep up that practice even now. When Jonathan first approached us and asked to think about how AI would impact identifiers, persistent identifiers, my immediate thought was to think from a more technical standpoint when thinking about these machine learning models. And I was mostly concentrating from the point of view of fulfillment, like Larry said on his slides. But later on, as I was thinking more and I was putting together the slides, it occurred to me that there's a more practical sense where, a practical place where AI could impact the role of identifiers for us as we are working on a movie production. So I'm going to talk about that use case rather than the fulfillment aspect of it. But hopefully we'll cover different tracks that Larry alluded to in his slides during the discussion phase. I thought they were all great. Let's see. Okay, so what is Movie Labs? Movie Labs is actually a joint venture of the 5 major Hollywood studios: Disney, Warner Brothers, Paramount, Sony, and Universal. And we do research and develop new technologies, anywhere from media creation all the way through distribution. In fact, a few years ago, we created a registry to keep track of the audiovisual content in the supply chain using DOIs. And more recently, we have put out a bold vision. It's called as a 2030 vision for the entire movie industry for adopting new technologies and approaches in the media creation process. Basically, that means we wanted to cut down on the costs and we wanted to cut down on the errors that we make as we make films and TV shows. And we have come up with a few principles, and if we follow those principles, as an industry, if we follow those principles, then hopefully we can cut down on several costs and errors. Because my use case that I'm bringing to the table today is about filmmaking, I just wanted to give a brief summary of what does filmmaking entail. It's a big deal. Usually a filmmaking process spans a few months, if not a few years, sometimes even a few decades. And obviously we rely on lots of storage of footage and audio files and lots of other kinds of objects. And it all amounts to hundreds of terabytes, if not thousands of terabytes of information. And we deal with dozens of standards and file formats, and lots of different vendors are involved during the filmmaking process. And of course, thousands of people are also involved. I mean, if you wait till the end of the movie and watch the credits, you will see the credits rolling for several minutes. And those are all the people and organizations that are involved in the creation of a movie making process. So it's a big deal. And there's lots of information that is being stored during this entire process. Now, because of all of it, we need identifiers to keep track of all of this information. And that is the subject of today's conversation. But before I go there, I just wanted to highlight a couple of critical aspects, one of which is the script itself. Once the project is greenlit by studio, uh, every decision that is being made during the filmmaking process would come from the script itself. While it is easy to think that the script usually tells you the story and the character arcs and whatnot, but it also informs us on several different aspects. How many actors do we have to hire? Do we need stunt doubles? Do we need choreographers? Do we need to rent planes and trains and cars? And, how many different departments do we have to hire? Do we need to have a costume department? If so, how big should be our budget for the costumes and whatnot? So everything begins with the script and everything ends with the script. So script is one of the most important documents during the entire filmmaking process. And if it's a live action movie, of course, we would cast actors and we would go on set. And sometimes the set looks like what you're seeing on the screen, which is a green screen environment. And most times these days, it's a green screen environment. But sometimes we also do shoot in live locations. Lots of different decisions are being made on set or in live locations as the actor's performance is being captured. I will talk about it a little bit later. And once all the footage arrives and once all the sound arrives, everything is put together on a timeline, and that's how we finish the movie. But there's a critical aspect of a movie making process that we need to keep in mind, and that is quite relevant for today's conversation. The first of which is that yes, we are using quite a number of technologies and SaaS environments and SaaS providers and cloud environments and so on. So movie making is actually a heavily technical process, but it is also a creative process in the sense that in most other industries, if you are in any kind of process-driven environment, you have a fair bit of sense of how the output of the process looks like. Even though you have not arrived at that output, you can clearly tell when something is right and something is wrong, and you can codify all of those as rules or policies. But movie making is different in the sense that there is no codification of what is right at the end of the process. It's the humans which decide after every scene, after every shot, after every VFX edit, whether something is right. Which means that one way to think of it is that movie making is actually a trial and error process. It's an explorative process, which results in the creation of lots and lots of data because it's trials and experiments. So we need to keep track of all of those trials and experiments. And that's the crux where we rely on identifiers. And the second bit that I wanted to convey is that because humans are involved in the process, we can't all, thousands of people can't all collaborate on the same process at the same time, which means that we actually break the movie making process into multiple different tasks. In fact, tens of thousands of tasks and workflows, which means that we need to keep track of all of these tasks and workflows and all of the inputs that went into those tasks and all the outputs that came out of those tasks. Again, we use identifiers for keeping track of all of this, and that is very important thing to remember. So what I'm showing on screen is a cartoon version of the relationships that we keep track of. Like I said, we don't all attempt to do the film all at the same time. So we start with the script, we break down the script into multiple scenes. Each scene results in some kind of a sequence, a few seconds of video that you see on the screen, but that is captured using multiple different cameras. So each camera footage would be a shot, and then if you're on set, the director needs to be happy with every single shot. If the director is unhappy, then you go through multiple different takes. And you rinse and repeat this process on set. And the same thing happens in a VFX or a visual effects environment too, where lots of different edits happen. The same thing happens from a sound standpoint and whatnot. So things are broken down into lots of different tasks, and we create lots of different data. So all of these black things that you see, black blocks that you see on the screen, are objects that we create. These are not the final objects. These are the intermediate objects when we are going through the process of making the film. So each of these objects gets identifiers, and all the relationships that you see using the lines here are kept track by those identifiers. We use references of those identifiers. So in summary, thousands of tasks and workflows run during a movie production process. Tens of thousands of intermediate objects, in fact, millions of objects are created. And all of these objects are assigned identifiers to name them and to connect them. And the final bit is important here, which is the movie making process actually runs for a few years, right? It's hardly ever a few months. It's usually at least a year, sometimes maybe 3 years. And it also depends on the director, right? Sometimes it could also span a decade, which means that all of these identifiers must be relevant during this entire movie making process, which could span years. So these are persistent identifiers, and therefore it's quite relevant for our discussion today. This is a video of a short movie that we were engaged in. It's a 15-minute movie, and these are the objects that we created in those movies, in that particular movie, and we have identifiers to keep track of each of those objects and also the relationships between those objects. I just wanted to show you this video to highlight that what I just said so far is not theoretical. It actually happens in practice, and this is a big deal. Keeping track of these identifiers is very painful, but we have to. Otherwise, if you see a footage, you have no idea what that footage is for. Which scene is it for? Which shot is it for? Which track is it for? Which take is it for? Is very, very important. Now, all of this could change. And so this is another way of thinking about what I just said, which is we begin with a script and we end with the film. There are lots of tasks and workflows, which then create lots of intermediate objects, right? So with the help of generative AI, or possibly even regular AI agent systems, we could imagine a future. In fact, some of this is already happening where we don't have to break down at the granularity that makes sense for us as humans. Instead of working on a given shot and a given take, you can possibly work for a complete scene altogether. You can use some of these video generative models to do things at a higher granularity than what we as humans are quite used to, which means that some of these tasks might disappear. Which means that some of the intermediate objects that we have been creating thus far for decades and decades may no longer be relevant. And this could happen in different stages of the movie production process, some on the visual effects side, some on the pre-production side, some during the onset stuff. So if we go on this logical continuum, we can end up with a scenario where we have this hypothetical AI, which is much more advanced than today's AI, that could absorb script and possibly a few instructions, and then can spit out the final set of assets that are required for distributing the film. So this is the future for sure. But if this really manifests, then we don't need to keep track of all of those intermediate objects for a decade, for a few years, right? Which means we do not need that many identifiers to keep track of it. So, but what I'm saying is not just endemic to the movie production process. In fact, it makes sense in other domains too. My wife actually works in the biotech industry, and even within their industry, they run these experiments. They capture information from, in my wife's case, they capture information about the human biological cells. They take images for about 1,000,000 cells during any given experiment. They use identifiers for keeping track of these various cells, and also the relationships between all of those different cells. And they run lots of different analysis on the images that they captured about these biological cells, and those analysis could span a year or 2 years or 3 years. And all of the identifiers that have been created for keeping track of these various images should make sense during those 3-year process. But what is happening is that they're able to use AI and short circuit some of this entire analysis pipeline. And it is now come down to something like, say, a few months of effort, or maybe even a few weeks of effort, which means the relevancy of all of these identifiers is cut down from being useful to keeping track of all of these various experiments and results, because AI is short circuiting the entire process and collapsing the hundreds of steps that are involved typically in any environment. The other point that I wanted to convey, which is hard to drive, is that in fact, it's not AI which is removing the need to keep track of the various objects. It's the efficiency that we are able to gain in this process that's actually cutting down on the number of objects. AI happens to be just an instrument for us to come up with that efficiency, but it could have been any other technology too. And this is the final slide, and I'm obviously not going to spend a lot of time talking about this one because I don't have that much time to talk about it. But this is the counterpoint, which is, so far I've only talked about scenarios where we are in a very controlled environment and it's quite process driven, and we clearly know where to get to. But if you're in an open-ended environment where any given application relies on information from different infrastructures and different devices, which are independently operated. Like Larry said, provenance and trust and compliance are critical, which means that identifiers are the way to keep track of all of those other infrastructures. Otherwise, if you will not know where things are coming from, and you have no idea whether you can trust the information that is flowing from different places. As a society, as we advance, obviously we are going to engage in creating smart cities and precision agriculture and self-driving cars. And all of this relies on infrastructures that are created by different organizations. So identifiers will play a critical role, in fact, even more pivotal role than today, which means the number of identifiers will increase in that open-ended environment. At least that's my hypothesis. So this is basically the conclusion. If you're working in a very process-driven closed-loop environments, then the need for PIDs might reduce, or most probably will reduce, because AI could collapse some of these workflow stages. But if you are working in an open-ended environment and interconnected data networks, then the need for PIDs will significantly improve. So that's my conclusion, and we can chat more during the discussion phase. Or now.
That's great. Thanks, Gita. There was one question that came in from Sandy. It's in the chat, which I think it's worth taking now. She was asking how are PIDs for aspects of a film used after the film is completed, and how persistent do they need to be?
Right. So obviously, there is an aspect that we call as archive, and we keep track of lots of different data that was produced during the film. The amount of footage that you actually see in the final film is only possibly about, I don't know, 1,000 of what we actually capture, right? So all of that information is there in the archives. And obviously, this is going to be the fodder for the AI training process in the future, I believe. So it is quite kept persistently, right? And all of these relationships too makes quite a bit of sense, because we can train models, machine learning models, to say, okay, why did the director not use this particular take? Why was the director unhappy with it? So all of that information could be gleaned from all of these various intermediate objects that we have been creating. But in the future, if we end up using AI, we will not end up with these intermediate objects. So I think we'll be okay even in the future. But the thing is, right now, whatever that we are creating, we actually keep them. So all of these identifiers make sense. But to answer the question, do we keep those identifiers and the relationships? I'm not sure about it. But we certainly keep the footage, and we have some relationships that we maintain. I was waffling. Maybe I'll be more coherent later.
Brilliant. Thanks very much. There's a lively chat going on, so that's terrific. Switch things up. I'm going to hand over to Josh to introduce our final speaker, Amir. Josh.
Thanks, Jonathan, and thanks, Giridhar. That was a really interesting discussion, and it's really stimulated a lot of conversation in the chat, which I'm looking forward to coming back to in the open discussion after we've heard from our third speaker. It's a real, I mean, Amir's an old friend, so it's maybe it's a bit obvious to say I'm a bit biased in saying it's a privilege to introduce him, but it's lovely to have him here to speak to us today. Amir is based in Australia. He's an associate professor in the at Swinburne University in Technology and the head of the Social Data Analytics Lab down there in the Social Innovation Research Institute. Now, he's also, I've worked with him on numerous PID-related projects. First one, I think, was one of the European Commission funded projects, ODIN, Orchid Data Site Interoperability Network, ending back in 2014. And it has been a real pleasure to work with him over subsequent projects and to kind of work with him on ways of experimenting with new ideas that emerge from some of that work, some of which is the kind of graphing approach of linking PIDs together. So also his work with Research Graph in Australia has been fascinating and has led to some really interesting stuff. So this is somebody who has got a very clear view on the structure of PIDs, the potential of them for linking concepts, activities and information together, and a really deep understanding of the challenges of bringing those things, those different kinds of data together. So I'm very interested to hear what you have to say, Amir. I will stop waffling and ask you to share your slides. And please, over to you.
A lot. Thanks, Josh. It was amazing introduction. Makes the job harder for me. So I'm going to talk about the role of AI in research in general. And PIDs obviously is part of it. And the other thing is that I'm going to use one of our recent projects in Australia as a case study, demonstrations of what we have done with AI and what is basically kind of possible in this stage. So as Josh mentioned, I'm leading a team that basically consists of different data engineers, AI engineers. We work with different researchers in diverse set of domains, and that give us basically a toolbox to kind of experiment with a lot of these technologies. So this is example of one of those applications. So generally speaking, in the context of AI, beyond using GPT or Gemini or those kind of typical chat-based interfaces, there are kind of three novel applications in 2025 for researchers, research administration, and research ecosystem. One of them is deep search. You might have actually heard about this. So the concept of deep search is basically almost all of these commercial larger scale platforms at the moment, they have this capacity to go out and they create a kind of a summarization of all the search results that you do. It is very useful for research because one of the things that it can do is that it can actually search PubMed and kind of publisher websites and a whole bunch of different academic environments like archive or bioarchive, summarize the data. In the case of the screenshot, it's from the Gemini deep search. It even produces a whole Google Doc out of these results. Then we have the second type of use cases. That's where the summarization of papers, that's the sort of things that we talked about this earlier. When a researcher have a research materials, you have text, PDF, documents, even video and audio, and you basically use a large language model to summarize those or talk to them. The Notebook LM from Google, again, another very good example of bringing this application to the front end, to the users, to the researchers, and make it a very, very useful capability. However, in the context of this talk, we're going to talk about another use case, and that is a knowledge mining from the research data. In this particular case, I'm going to talk about the research information more than actual data, but the same principle will be applied to that. So this is, we are kind of at the moment in the level of quality of generative AI models that they provide high quality results with minimum hallucinations and quite a good instruction following. And that provides a good pathway to a lot of things that I'm going to talk about those. But first, the context. So this is, I'm going to use a case study or a project we have done in Australia. This is a project funded by Australian Research Data Common, or ARDC, in Australia, and it's called the Research Link Australia. So Research Link Australia, or RLA, basically is created as a bridge between the research and industry, and industry here is a loose term, is everything that's not university. So governments, not-for-profits, social enterprises, small companies, big companies, and so forth. The idea is that how do we actually make the industry, potential industry partners to connect the researchers? How do we create the research collaboration? How do we make domain experts and researchers find each other? RLA has a discovery portal. There is a service that ARDC provides. So that's a kind of quite a standard platform here, but it also have a number of different projects. And we're going to talk about one of those, which is in a health space. So RLA did a community of practice for health and well-being. This one was created in the public health space. And the idea was we bring in a health organization from different kind of granularity. We had a medical research institute, we had a digital health CRC, which is cooperative research centers, health research institutions at universities across 2 different universities. We had a not-for-profit organizations like Info Exchange and Research Graph, and then we have a kind of a research environment across a spectrum of stakeholders, which is HEAL. So we had quite a diversity of the organization who participated in this. These groups collectively try to actually answer basic questions about their research network. They were trying to understand what are their research capabilities and capacities. The capabilities are the one that they have already in their group, the sort of expertise that they have across their staff. What are the things that they can get out of their network? There's potential capacity that they have, capacity of growth. And then the other questions such as, what are the current partnerships? What are the potential partnerships that they can establish? How do we measure the impact of their collaboration? And so forth. We're going to focus on the first 2 questions, the research capabilities and capacities. That means inside the house and in the collaboration network. So we use the data co-op workshop methodology, which this one is mainly consists of running workshops that uses the data from multiple sources. So we obviously had a data from partners that includes the research grants, the research publications, the information about the researchers, research organizations, and so forth. We then also had the RLA data. RLA, Research Link Australia, managed by RDC, currently holds quite a large graph. It's about 5 million nodes, includes majority of publications by Australian researchers, the fundings from government, a lot of ORCID profiles. Basically, it links the DOIs to ORCID, to the grant records, a lot of those that don't have a persistent identifier, and then link all of them in a very curated way to organization identifiers, including ROR, Wikidata, also connects to the Australian Business Registry. So quite a comprehensive graph. We basically, in the workshops, we use all of these data, and then we answer the question. We try to produce insights, and I will take you to some of those. And then we will try to actually find out what information are valuable to the partners in the project. So across this group collectively, this is the kind of the, if you like, the offering by the partners. So apart from RLA, we, in these partnerships, we had information about 22,000 researchers. We had about 3,000 grants, about more than 8,000 research outputs, and collectively across the affiliation of projects and researchers, we had about 5,000 organizations in this network. So one of the questions that I mentioned we had was, how do you measure the research capabilities of this group collectively? Well, there is one way of doing this, and that's a manual way. So we basically, in one of the workshops, we had the stickers that the different members of this group, they had different ideas. So we were just kind of sticking them to the wall and trying to summarize them. It's quite a laborious process. And actually, what we realized is that very difficult for human collective to come up with a comprehensive view of things. There's a lot of different contradicting ideas that make it difficult to come up with that result. So that's one of the areas that we employed AI. What we did, we used the open source AI model. We passed all the grants and projects descriptions to this model, and then we asked for different classification methods. Now, later on, I will talk about the human in the loop model, but it's very important to realize that AIs actually can produce so many types of classifications. And what we have done in these workshops is that producing different classifications, get the feedback from partners, based on those information, refining the data, and also refining the prompt in order to get to the classification that makes sense for everyone. So on that note, the classification that we kind of got to that or settled on that include 4 pillars of the health and well-being, social services and community support, environmental sustainability and innovation, and technology and data science. And underneath, we had the subsections here that each one of them was basically drives from those project descriptions that I mentioned. So then we take all of these things to the research graph engine that Josh mentioned. We have the capacity in Australia to produce these kind of visualizations quite rapidly. We use that data to produce data insights that we could basically open the discussion with the partners. And the use of this is that, for example, in this case, if I zoom in kind of on that part, you would see that different partners have different profiles based on that classification. So like Origin, which is a medical research institute, have a majority of its profile about health and well-being, a little bit about social services, and then technology. In contrast, the last one, which is a digital health CRC, has most of the profile about the technology side and some about health and well-being. So this is where we could see how these partners kind of come together and what does it actually make sense from point of view of their collaboration. But this is a very coarse-grained classification. So going into this, what about the individual partners? We have used basically the same technology, but for the individual organization, obviously with different prompts. And that way we are looking for a more fine-grained classification. So for Origin, that we just talked about that, if you go to the detail of these, AI can provide a much more refined classification. So from that, we can get a 5-level classification. If I just make this one as a table, think about this. Initially, it was health and well-being, and then most of it was health and well-being, and then some technology part. But then that actually translates to a whole new set of topics. So they are working in the digital and virtual intervention, innovative therapies, pharmaceutical interventions, social and environmental factors, and youth mental health. And under each one of these categories, and they have subcategories. So that's where we can dive into this classification. And then when we look across different partners, then it looks now very, very different. So there's different type of classification for each one of them is possible. So we learn kind of from that exercise that there are different answers simultaneously can be true when we talk about the classification of capabilities. So we map those information to the collaboration networks. This is one of those examples of putting this data into the kind of secondary use. So here we can see the collaboration network of Origin. So they have about, in their network, they have about 174 organizations across 27 countries. That's the insight on the top. Now, using the focus area, which is that refined classification, we can basically focus on different areas. We can find, for example, all organizations who are partner in the app-based digital health. And then that way, actually pull the information related to that and focus on the related countries and researchers and information related to that area. Also at the collective group, again, if you remember, we had a bigger classification of health and well-being technology, social services, and environment. Again, the same scenario, focusing on one group of health and well-being, help everything to kind of focus onto that point. If you remember, one of the conversation earlier was finding the partners and partnerships. And that is where these kind of collective visualizations was very helpful, because we could open the conversation about who does work with what organization and who doesn't, and what are the opportunities here in this space. So if I want to summarize this to a kind of a lessons learned from this exercise is that the domain experts provide a substantial role in making generative AI useful in this kind of context. It provides two components. One is that it helps with the annotation of data, refinement of data, providing a better data. You probably have heard about a concept that called RAG, or retrieval augmented generation. That's underlying component of a lot of these activities, and that requires domain experts. In the other side, it also that feedback loop that as we kind of get feedback from domain experts, you keep refining your prompts. And the result of this, you get a different result from AI or hopefully better result. Okay, and I can finalize by saying that this is a screen, kind of a photo from one of our workshops that I mentioned earlier. The other function of AI was to kind of keeping these meetings very interactive and lively. It actually provided and facilitated a very, very good discussion between all the partners, continuously providing new perspective, different from the initial annotated materials. And it provides a very, very good platform for creating what we call data-informed dialogue. So it helps the group to actually understand data quicker. And it also helps them to identify exactly what are the strengths or different novelties that they want to introduce into the mix. Okay, on that note, that's it. Thank you very much. Thanks. And I believe we can open to questions. Let me stop sharing.
Fantastic. Thank you, Amir. And I think it was nice to hear that the contrasting approaches to AI there. There are some very hypothetical future focused ones, and coming back to that current and very applied use of AI to improve the current systems is kind of a nice, is a reality check, but it's also a way to think about this as just that kicking off point, which is really fascinating. And I hope that is going to be a lively discussion. I would like to open the floor to a general discussion. I might invite Larry and Giridhar to put their cameras back on so we can kind of have that, if you like, a virtual panel, if that's okay. Thanks, Larry. Hi again. Hi, Giridhar. So, folks, we're really interested to hear your thoughts. There have been some really interesting discussions. I think Uwe Schindler came up with a really interesting point in the chat, which is what happens if AI decides it doesn't need PIDs anymore, which gets to the essence of the question today is, will AI render PIDs obsolete? The other point that I think we made in our session description as well is, how could AI make PIDs more useful and more valuable? The example there might be automatically generating metadata, given that one of the big problems we have with PID registries, etc., and the metadata associated with them is the gaps. So there are ways that you could imagine current uses of AI, especially LLMs and generative transformers, actually reinforcing our reliance on PIDs. And longer term, what Tom described in one of his comments in the chat there as magic do everything boxes, might render PIDs completely obsolete. Now, I'm going to open the floor to comments now. Josephine, you were the first person to put your hand up, so I'll ask you to unmute and join the discussion. Thank you.
Yeah, thank you very much for these very interesting presentations. I've been thinking myself a little bit about these very topics, and also trying to see where the topic of research reproducibility fits into this discussion. So I work within a collaboration network consisting of 6 different Northern European partner countries. It's called Knowledge Exchange. And so we are in a very early stage of forming a working group around these topics, where we are trying to figure out how PIDs can be used as sort of trust markers in an ever-growing AI-driven environment, and also how to sort of cater for transparency in doing so. And so my question relates to the session's introductory description, that it says, where some people argue that Gen AI removes the need for persistent identifiers. And so going beyond only discussing increased levels of trust through PIDs, I'm quite keen on hearing your thoughts on the role of PIDs in ensuring research reproducibility in this AI-driven environment, and how can we facilitate the transition towards increased reproducibility here? Because I think PIDs are absolutely crucial in this aspect. So do we have any thoughts on this?
Thanks, Josephine. I'll ask our speakers first of all. Do any of you want to respond to that question?
Well, sure. Yeah, reproducibility at anything like the way we manage stuff now requires the ability to go back and see what the inputs were and how they were used. So I think the answer is yes. When I mentioned scientific workflows, which is not unsimilar from movie making workflows, except you might have a more strict audit process if you're going to approve a drug. You need the ability to go back and sort these things out. Where did they come from, and so on. So yeah, I would say so.
So almost like using PIDs for the audit trail through the AI decision-making process or refined process there is an interesting approach. Larry, you did have your hand up to ask another question. It's come down.
Yeah, so I was going to address, will AI make PIDs obsolete? So that's an interesting and speculative question, but not one that we can be very operational on. If that happens, it's not going to happen tomorrow. And in the meantime, we will have to deal with it and have the existing systems continue to work. So that's, I'd say it's an interesting question going forward, but not one that we have to deal with today.
Well, can I raise my real hand?
Yeah, please go for it.
Answer to that, Larry's point. I think what I was trying for in my presentation was it's actually happening even now, right? So the case that I made, some of it is hypothetical, but some of it is actually not. So we do rely on persistent identifiers for keeping track of these various objects. And we are talking about millions of objects, especially if it's a TV show, then we are at least an order of magnitude higher. And we do rely on these identifiers to keep track of these various objects. But AI has provided us a level of abstraction there where we don't have to think the way that we are thinking currently, but instead we can just provide it the intent of where we want it to go, and somehow magically or semi-magically, it's accomplishing the very same thing that we wanted to accomplish without creating any of these intermediate objects, right? For us, at least in the movie industry. And I could say the same thing about the biotech industry because my wife works there and I have a fair bit of insight into how things are working there. And so I would say that, yeah, we do not need that many identifiers, especially if it's a very closed loop, process-driven environment. So it's something for us to think about.
Yeah, I think the closed loop, I made a little comment, closed loop versus open environment. It's a very important point here, the one that hadn't occurred to me. And I was involved in this project probably 10 years ago, and I had to conclude that as information moves from one environment to another, you always lose. You lose something, you lose precision. And so you have to be able to go back into that other environment and see where did that come from and so on. So unless at some future point the entire planet is a closed system managed by AI, then we certainly are going to need to be able to track where things come from and how they interact with each other.
Right. So one final bit about the initial question that was asked about reproducibility. So in one way, things are shifting around reproducibility at least in my wife's company's example, where they focus a great deal on human biological cells, is that some of the traditional biopipelines that they have been using are currently being replaced by some of the AI models that they're putting out. And the upshot of that is instead of focusing on reproducibility, they're focusing on explainability, where yes, some of the AI work is non-deterministic and could possibly end up with a slightly varying results. And you could see it in AlphaFold too, where for a given protein sequence, it could come up with multiple different protein structures. But as long as you're able to explain things, at least it would check off some of the boxes, if not all of the boxes. So that's an area that's currently being looked into. I'm not saying that it's an alternative to reproducibility, but at least it checks off a few boxes there.
I just want to jump on that, Giridhar, because it struck me listening to you talk is one of the things that is very helpful sometimes to understand are the dead ends or the roads not taken, and identifiers for those, recording those decision points, recording the rejection, the reason for the rejection, and so on, and having that identified is useful because in different contexts, that information could be useful for a different kind of research purpose as well. But it also helps to provide that kind of, it speaks to kind of, I thought, Josephine's point about reproducibility is if you can track back through decisions that have been taken and where things have been rejected and the reasons for that, that is itself useful information and enables you to check the validity of the decisions that are being made. Amir, your hand is up, please.
So I'm just thinking about the answer to this question, and there are two aspects to this. There is one promise or the idea behind this question might be the fact that we probably don't need to have a structured data sets. That translates to we do not need a graph across a scholarly communication to use AI or to use any kind of software platform that uses AI. That by itself is not correct. Like a lot of our work that even in my presentation, we build knowledge graphs, which is even extended graphs, top of the persistent identifier graph. So availability of a structured data substantially improve the quality of outcomes that we get from AI. So the structured data existence of generative AI does not mean that we no longer need the structured data. The other thing is that the compute that requires and the infrastructure that needs to create, if you like, that global AI that manages and runs everything around a scholarly communication, you're nowhere remotely close to this. Like still a lot of us that uses the generative AI for knowledge mining, we are still struggling for a lot of disambiguations across the different persistent identifier nodes, for finding the right DOI or right ID for organization. Is still disambiguation of researchers using this generative AI is not a zero-shot kind of prompt that you might assume, and that how it would work. It doesn't. So as a result of this, still there's a huge chasm between the current technology and to the point of getting to that ultimate intelligence that you basically need AI to observe everything and you don't need a PID. So I think at the current environment, persistent identifier plays a substantial role, and I can see that this is going to be continued for at least for maybe a decade to come.
Fantastic, thank you, Amir. I'm just going to note that we had another hand up, which has gone down as we dove into this topic a bit. Tom Demaranville, did you want to chime in? I'm not sure if you're on this topic.
I can chime in.
Question came up earlier, so a different one.
Yeah, I'm chiming in simply because we've had these discussions at ORCID. We've chatted about these kind of things with the board. So I don't know. Is it a question? I suppose it is a question, which is I'm referring back to something that was in the comments, which someone said, I think, what happens if AI decides it doesn't need PIDs? And then I was racking my brains trying to think of an example where it did use PIDs, right? Especially generative AI. And I don't think it relies or understands PIDs in the same way humans understand PIDs at all, right? So predictive AI uses PIDs. You know, we already do these things, right? We cluster works around people, right? And PIDs are an input into that. It makes sense. But Gen AI, as far as I can tell, doesn't really care about PIDs already. I don't know if anyone's got a counterexample.
Well, I can give a counterexample to this, is that a lot of, going back to the ORCID scenario, a lot of questions and prompts that you get out of the engines like ChatGPT comes out of the data that use the training data that use underlying of this is all of those PID connections. So you can actually alter that. So this is some of the work that we have to do to fix these records. So you have to basically fine-tune your model by putting the right PID connections in order to get AI to give a right answer. So the fact that you actually ask a question and that question, that conversation doesn't need a PID, that doesn't that still requires a PID ecosystem underneath to train the data, to train the AI in order to enable that chat conversation. So chat is almost like a glorious information retrieval engine, top of the underlying data. And underlying data is basically structured data. Now, in the case of a scholarly communication, that structured data is a persistent identifier graph. If you're in finance or in other sectors, that technically is your database. But you need the data in order to train the AI.
Right, but so it's not necessarily the property of being a PID system that it's used, right? It's the fact the PID system contains the structured data describing the domain, right? Yeah.
And the links. My sense and experience is that the links are more important than the metadata.
Right,
Because
okay.
the metadata can be augmented using multiple sources. PIDs are one of the most common use cases for the kind of term everyone is familiar with, that hallucination. So not having the right connection, that's where you get the most incorrect information. One of the most common cases that we use, or kind of always check, is ask generative AI to give you citation of something. It gets it wrong a lot, and because the persistent identifier graph is not quite comprehensive there, causing a lot of underlying data problems.
Just to bring in a comment, an observation from the chat, Seong-Young Kim from Washington University says, I've seen generative AI create fake DOIs as part of their hallucinations. So it's that challenge is who's going to be checking the accuracy of that generated data. Larry, your hand is up, please. Do you want to chime in on this discussion?
Yeah, I want to first just agree with Amir, but add to it that if you ask for the more recent deep research, if you turn that switch on, you get a lot of references at the end, and those are frequently DOIs or other kinds of PIDs. But I also wanted to address some stuff in the chat. That was the second one about maybe we shouldn't trust all this, and that's my pay attention to this point. What I worry about is someone coming in, waving an AI flag and saying, you know, everything you're doing is wrong, and they're selling something. And that, so we have to maintain our current systems functioning well, and then utilize these new technologies as they come in. And we have to do that carefully, but not just for our, you know, the organizations we feel loyalty to and so on, but for the good of the knowledge management and future activities.
I think that speaks back to that comment from Emmanuel in the chat here as well about assigning PIDs an important task in curating our data, and leaving it to AI would be a bit of a dream. Can help but shouldn't control was that observation. Tom, back to you, please.
Yeah, I was just going to comment on that. I think that's the crux of the issue, I think, is how much trust you have in the output from, I don't know, an LLM. And if it's going to get it wrong 20% of the time, then there's always going to be need for human curation of this kind of information. It doesn't do that kind of activity for us. And, you know, in the use cases of PIDs, of absolutely identifying the correct entity, this use case doesn't go away, right? Just because you can generate new content based on those facts still need to be collected, organized, managed, delivered. So I just don't see it as this existential threat right now. Maybe there'll be new developments in the future that will change my mind on that, but what we're seeing right now in no way removes the need for the underlying data structures and communities of practice around those data structures that make that happen. I don't want to speak for the DOI folks, but Orchid, we have brought a huge community of over 5,000 integrators together to do this work together as a common good. Like 9.5 million active users creating their records every year. That kind of activity, I think, is the most important activities we do. It's much easier to build technological solutions to problems than it is to get people to actually use them, do the right thing, and get different players in the community to work together is really, really hard. And that's not something that will ever be solved by predictive or generative AI, right? So the organizations underneath PIDs, they'll definitely need to exist as well. And even if our developers have an easier time building functionality, which again, I think is debatable, we will still need the organizations and the effort to coordinate all the efforts and organizations like RDA to convene these kind of meetings, or the whole thing falls to bits. And we just don't want that to happen. So I'll get off my soapbox now.
No, I think that's a really important point, Tom, and it's a case of kind of the risk of throwing the baby out with the bathwater, right? It's like if we all jump on the bandwagon and try and do, I'm mixing metaphors horribly, I apologize. But it's that everybody trying to do the cool, exciting new thing and forgetting about to nurture the real value that comes from the human community of practice and expertise and experience that underpins the goals that you are trying to achieve. And the classification of those goals, the prioritization of those goals is something that's really critical. Giridhar, over to you.
Yeah, so it depends on the day when you ask me these kind of questions. Today I'm more upbeat about AI, but tomorrow I'm more upbeat about humans. So don't take anything that I say very seriously. I'm just thinking out loud here. A couple of points that Tom made really made sense to me. So one of which is trust, right? And we explored what does it mean to trust something for several number of years in my previous organization and even in the current organization. And one thing that I always come down to is trust is about consistent results, right? If a given system consistently produces the thing that you expect it to produce, and if you're happy about it, then you have trust in there. It so happens that in the absence of those trusts, we are digging one layer deeper with the help of PIDs to assure ourselves that what is being produced is according to what we want it to produce. So if AI consistently delivers whatever that it is that we ask it to deliver within the realms of what is possible, right? Do we still need these PIDs to track the provenance or not is a question that needs to be explored here. And the second point that I wanted to make, it's slightly related to this, but also moves us in a slightly different direction, is that human thinking is always path dependent, right? And only occasionally we come out of the path that we have tread along to think in a radically different way, which means that currently we are operating in an environment where PIDs make a lot of sense. But AI is creating a level of abstraction here, and we are still yet to trust that level of abstraction. But once we do trust it, then we no longer need to look into the current ways of doing things. Like, when is the last time that I ever thought about how operating systems work? I have a deep computer science background. I know about lots of what happens in an operating system, but I don't think about it on a daily basis because I trust it. And then now I'm operating at an application level, or maybe even at a cloud level. So I stopped thinking about all of those things. So the question is, for all the things, or at least for some of the things that PIDs enable us, do we ever get to a stage where we can stop thinking about it because we are operating at a slightly abstracted level, is a question.
That's a really interesting question. And I'm conscious we've got 10 minutes left in the session. But we will come back at the end of this to some of the next steps and what some of the prep we'll be doing for continuing this conversation in Brisbane. So hopefully we can come back to that and discuss it in much more information, much more detail. Amir, you've had your hand up for a while, and then it's Tom, and then I think we'll go to Jonathan, and I will wrap up and talk about our plans for the next session. So Amir, over to you.
Okay, so I'll just make it very, very quick. We talk about world existential threats to PID. I'm going to flip this and say, if we get to discuss this in Brisbane, maybe the next question should be, what is a unique opportunity for PID? So this is now a very, very good opportunity and technology platform to improve the quality of the persistent identifier graph. A lot of problems that we already have in our infrastructure can be much easier rectified. The other thing is that we can create new application layers that didn't existed before. So a lot of these PID services can have the very bespoke services that make their data much, much more valuable. I'm going to stop here. The rest of this conversation hopefully will happen in Australia, and everyone is coming.
I think that idea of flipping it and saying, what is the opportunity space here? I saw a couple of thumbs ups and nods on the screen for that discussion. Tom, your hand is up, please.
So yeah, just on Amir's point, I think, yeah, reframing it in terms of opportunities is a really good idea. I'd like to explore that definitely. So from a personal point of view, so that's good. But I'm just going back to the example given, it's about trust, but it's like, and trust for whom, right? So a lot of the early adopters of things like PIDs are essentially librarian type staff, information professionals, these kind of people, rather than the people consuming the content that's identified. I doubt, in the movie business, I don't know, but I doubt the director really cares what all the identifiers are, right? They just want to bring the thing together and make the thing, right? Similarly, if you write a book, it gets an ISBN. You don't really care what that is. You won't remember it, but it's very, very useful for the people that are managing the information about your book, right? So who are persistent identifiers for is actually a really important question when thinking about what is the impact on PIDs from AI, right? So will it make you, like your regular researchers, for example, care more or less about PIDs? I don't know. But will it remove the need for the information professionals to care about them? I think it won't, right? Just similarly, like, I don't know anything about operating systems either, right? But if I was a low-level developer or creating embedded systems, I would need to know about operating systems. So it just depends. What are the use cases that we're talking about, rather than persistent identifiers as a whole is a massive nebulous subject. I think if we're talking about the impact of AI on PIDs, it's actually the impact of AI on specific use cases of PIDs that maybe is slightly too much detail for this meeting, but it makes a huge difference because I think it can impact some and it won't impact others in terms of actual uses.
I think there's a conversation that's been going on, a bit of quite a long conversation in the chat, which I think is very pertinent there, Tom, as well, which is people talking about why some groups are using kind of their own customized layer on top of DOIs for a particular use case, and RAID and IDA are examples that were raised there. Why the recent US kind of desirable characteristics of a PID list that was drawn up, which is different from a desirable characteristics of a PID list that was drawn up in Canada just over the border last year. And you look at this and it's like the context is absolutely the most important thing that generates the value for all of these things. So your point about some use cases will be negated by the use of generative AI or future kind of voguish artificial intelligence technologies. Others will it will reinforce the need for PIDs, and there will be a lot that fall in the middle. And I think that context point is really key. We've got just 5 minutes left in this session. Jonathan mentioned at the beginning that there is a follow-up kind of partner session to this in person. We'll have a panel discussion in Brisbane. We're hoping to get 2 or 3 of the group co-chairs there as well in person to do this. We're just kind of figuring out how that's going to work with everyone's travel and budgets and things. But it should be a really lively discussion. So I would just like to say, please do join us there in October for the next in-person plenary in Brisbane in October this year. But maybe, Jonathan, you want to talk a bit about kind of how we're going to go forward with some of the results of the discussion, some of the topics we've identified today.
Oh, yes. Thanks, Josh. Well, first of all, I just wanted to say huge thanks to Larry, Gida, and Amir. Really thought-provoking. I tried to capture a few things on the collaborative notes, and others did too. But I thought that that Larry's we need we really all need to be experimenting with this. And I'm thinking maybe that's something to think about for the next session, is we need to ask what if this, what if this happened? And that's in the chat sometimes, you know, what if all research, AI is doing research, then its outputs need to have identifiers too. What happens then? So I really like that approach. I thought Girdar's sort of closed system versus open systems, I think that's another thing we could use. Maybe building what Amir said of some use cases. Okay, what happens in closed systems? Okay, but we also have lots of open systems that fall into the decision identifier area. So I thought that was really interesting. Open for suggestions from everyone. It is an open. I'll post something onto the group and ask for suggestions. But I thought I need to process some of the comments. There's been some terrific comments. I'll cut and paste those into the collaborative notes so that we have them, because I'll get them afterwards. And all that I think remains is just to say thank you to you all. Thank you for participating, and I hope you got something out of it. Don't be strangers. Ask. Continue the conversation. We had no idea really coming into this. We just thought we need to talk about this. And as Tom mentioned in the chat, I mean, we sort of started from the generative AI because that's what everyone's talking about and everyone's asking what ifs. But actually, of course, it extends to any technology out there that is potentially, mimicking some form of intelligence and using the information that we have. So thank you all. I wish you, whatever part of your day, either the rest of your day or the rest of your evening, a wonderful time. And thanks to my co-chairs, to Josh and to Nabucco. And see you next time. We'll see you online.